Hi, I'm Tom Henriksen from the DevOps Online Summit, and welcome to our keynote interview with Julia Wester. Julia, introduce yourself to the people here at the DevOps Online Summit.
Hey, first, thanks for having me here. I'm Julia Wester, as you said. I'm the co-founder of a small company in Sweden called 55 Degrees, and we provide products and services that help people essentially get more done with less stress. So our current flagship product is Actionable Agile, and that's an analytics suite focused on using flow metrics to improve outcomes. And it does that by helping people ask the right questions and make better decisions. So I'm just really glad to be here today and geek out with some people.
Excellent, excellent. So your title today for this session, Julia, is Beyond the Pipeline, Stabilizing Your System. So give us kind of the nutshell of what you mean by that, Julia.
Yeah, well, I've been around the DevOps movement for quite a while, and I know there's such a focus on that last mile from commit to deploy, and that's really where that all sort of began. And once you sort of get that sorted, you realize there's a lot more there. So there's all these, shifting left and all these different kinds of concepts, BizDevOps, BizSecOps, et cetera. And so it's time to go beyond that first step of your DevOps journey and start looking at what it really means to stabilize your work system, because that's the system I'm talking about, not the tools that you use to get, not the Jiras and the Azures of the world, but the system of how you get work done, your policies, your processes, all of that, and making that stable so that your life can be significantly less stressful. So that's what we're talking about today.
Yeah, I think we can all use less stress, especially after the last year, right?
Yes, drama-free workplaces, reducing drama, reducing stress, and realizing we can get the same amount of work done and maybe even more without having to have all of that stress. I mean, some is good.
Yeah.
But a lot of it is unnecessary.
So true. So true. So what does stabilizing your system look like?
Yeah, there's a really good construct that we can look at to define what a stable system means as far as this kind of intangible process, this work process. And that's something called Little's Law. And I'm going to give you a formula, and you're going to be really tempted to use this formula to find precise answers for things. And we'll talk about why you shouldn't do that. But it essentially means average throughput, or the average rate at which we get things done over time. Your average throughput is equal to the average work in process divided by your average cycle time. So let me just define a couple of terms there. I said throughput is the rate at which you get work done. Okay. Work in process or work in progress is the amount of work you have that you've started but you haven't finished. So the average amount of that you have in your system at any given time. And cycle time is the duration, the elapsed time from once you start a piece of work to when you finish it. So again, Little's Law is average throughput is roughly equal to your average work in process divided by your average cycle time. And people hear that and they think, great, now I can find out exactly how long it's going to take me to get work done, or I can flip the X and find out how much work I should have in process at any given time, yes, and all of that. But there's a couple of problems with that. It's one, if you heard me, I said average, like average everything. Yeah. Average throughput by average width by average cycle time. So if you focus on averages, you'll be average, right? We don't want to be average. But there's a lot of assumptions behind Little's Law about what your system would have to look like for that to be accurate, right? And these assumptions are never going to be true for all of us, but that's okay for two reasons. One is that this formula shows us that there is a relationship between these three things, between the amount of work you have in your system at any given time and how long it takes to get that work done and how much you get done in any one time period. So we can start to investigate and look at these three things as a symbiotic set of elements that, if we touch one, something's going to happen in one of the other ones. And so we need to be looking at those together all the time. But then also, if we start to learn about those assumptions, what they are, even if we can never be exactly perfect at making them true, the more we can make them true, the more predictable and stable our system will be, or the more stable the system will be, and stable systems are predictable. And there's a whole bunch of benefits you get from that. So are you curious as to what some of those assumptions are?
Yes, yes.
Okay.
Definitely.
Okay. I'm rewording these into things that are just, I like to, not use all fancy speak. So these are in my words. And I'm going to go over some of the 4 of the most important assumptions of Little's Law.
Mm-hmm.
One is that we start work at approximately the same rate as we finish work. Okay. So now a lot of us, I know I was an IT manager for a long time, and we had to do quarterly business reviews showing things like our open versus close rates.
Yeah.
That's sort of what we're talking about right here. Do we start work at approximately the same rate as which we finish work?
Mm-hmm.
There's also this assumption that all work that enters the system will eventually exit the system. And that, yeah. But the good thing is that doesn't mean that you have to finish something even when you decide it's not worth doing. You can finish that as I'm not doing it, but you don't want any work to disappear. And then, it's one of those more esoterical kinds of assumptions. But when you're starting to track your metrics, it's important that everything that starts has a close point as well,
Mm-hmm.
and it just doesn't disappear. 2 more tangible ones are that we should have roughly the same amount of work in process in our system over time. So if we're looking at a time period, the less stable the system is, the more that changes through time. When we're looking at a stable system, we see consistency of all things, rate at which we start and finish work, a rate of how much we have going on at the same time. But perhaps one of the most important assumptions is really that we don't let work age unnecessarily. Okay, so that means once we start a piece of work, we want to commit to making that a priority and getting it through. There's a lot of, have you heard of Kanban?
Yes.
Yeah. Okay. So, I learned Kanban, I teach Kanban. The magic wand is like limit your work in process, right?
Yep.
And that's super important. But it's not really enough. If I could limit, I can limit my work in process and say, we can have 5 things going on at one time, but I can ignore 2 of them and just let them sit there and sit there and sit there while I'm cycling through other things in those 3. And I'm still staying in that rule, but I have these items that when they finish are going to be extremely old, and that's going to skew all of my data.
Metrics, yeah.
All of my metrics. And when we talk about what predictability is, it's really a outcome of your past performance, your metrics, right?
Mm-hmm. Mm-hmm.
So these are the basic assumptions that we want to try to look at to define what a stable system looks like for us. And you may add more things on, but those are some core things right there. And if we do these, it can really, really improve our predictability. If we talk about predictability, essentially what most people mean is that you deliver often and fast with good quality, because you can be predictably bad or predictably good, predictably slow or fast.
Yeah.
So when we just say predictability a lot of times, and we have to assume we know what we're talking about.
Mm-hmm.
But generally, if I'm looking at a chart of all my cycle times, and each item shows the age of a piece of work when it was finished, predictability, I could tell if I'm getting more or less predictable by how compact those dots are versus how spread out they are.
Mm-hmm.
The more compact they are, they're in a smaller time frame versus when some are really fast and some are extremely long. So looking at metrics and determining what you mean by predictability is really sort of critical there.
When you come into a company, Julia, and people start talking about predictability, I'm guessing you have to kind of level set and make sure we have an agreed understanding, right, on some of these words.
Yeah, I do think that's important, because on one hand, it really doesn't matter what word you use as long as there's a common understanding of what you're trying to accomplish. So I don't have holy wars about, is it lead time or cycle time or flow time or what? I don't care. Yeah. I just want us to know that, say, from start to finish, that's what we're talking about, or point A to point B. The same thing with predictability. Yeah. Okay. You say you mean predictable. What does predictability look like to you? What are you trying to achieve? And the reason why I think people want predictability so much is because they know what they're getting, and translating that to us in the daily life is the value to us is that we can tell people what they're going to be getting with relatively good confidence, right? So being predictable doesn't just make our customers or end users happy. It makes us happy because that makes forecasting less painful, right? So being predictable is really, really important.
So is it because you talked about stabilizing first and then you talked about predictability? Does it need to go in that order?
Yeah, that's a really good question, because I talk to people all the time about using metrics, and they're all at different points of their journey. Yeah. But the first step, before you can be more predictable and before you can forecast with happy forecast, you have to measure your system, right, to see what's going on. You use that historical data to create what we call probabilistic forecasts. So that means I can look at my cycle time data and say 85% of the time our work gets done in X days or less. You might be thinking SLAs, but you could totally use it as that. But really, it's like something to let us know what we should expect of ourselves. Yeah. It doesn't have to be outward forecasting. So when we think about, looking at forecasts in that kind of range, if we can do that with unstable data, or we can do that with very stable data. So what I tell people to go back to your question is, first, look at your data, see if it looks really, predictable or really spread out or whatever. Yeah. In either situation, you can still use your data to make probabilistic forecasts in seconds using the right tools. But if you want to be happier with those forecasts and you want them to be more trustworthy without having to account for so many outliers that really it's almost not usable, then you have to start working on predictability. But you can always take that data, even if it's really unstable, and start to use these mechanisms and then track your ability to forecast better over time. One of the things that we do, we call, that thing that sounded like an SLA, we call it a SLE, a service level expectation, because it's something of ourselves that we expect based on our past performance. And so we might track, say, our 85th percentile SLE. And we use that to become more predictable. And we can talk about that in a second. But then as we start to manage our work, looking at all of this stuff, we'll see that the things that we do will cause that 85th percentile to stay at like 14 days. If that, 85% of our work finishes in 14 days, the choices we make will either make that line stay there, or make it go up, or make it go down. And so if we are working on improving predictability, we are working on making that line either stay the same or go down, which by default improves your, it reduces the outliers that you have and improves your confidence in your forecasts, or at least makes people happier because the forecasts will be less and less far out.
Mhm.
Maybe it would have taken you 6 months to do this thing, but now you're into 5 months because you've improved your predictability. Maybe you're getting down to 4 months or something like that. So yeah, focusing on system stability improves predictability, which then improves your forecasting. It's much
Forecasting.
like that Little's law where those three things are connected. These three things are connected, and there's absolutely no way you break that connection.
Hmm.
It just will always be a truth of work.
And I'm guessing leaders, especially in organizations, like the less painful forecasting.
Yeah, well, it takes a while for people to trust the fact that you can use your data
Hmm.
to do a forecast. What we're very used to is people getting expert estimates and spending a lot of time breaking down work, thinking through what needs to be done, uh, writing that down, and coming up with a plan and a duration. Um, and there's a lot to be said about experience and expertise. Um, but we think that your past performance is the best indicator of future performance.
Hmm.
And a lot of times we don't really know how long it's going to take to get those things done that we're breaking down. We put on a lot of false confidence in that, oh yeah, this will be like a week or so, and this will be two
Yeah.
weeks. And there's so many different aspects to account for. And so we end up spending all of this time and still providing a very inaccurate estimate in the
Hmm.
end. So do all that if you want to, but we want to get people to a point where we can give not just one estimate like we historically do and bet all the marbles on that,
Yeah.
but we get forecasts in seconds based on your data with a probability associated that shows you the risk associated with that date.
Hmm.
Because when I say 85% chance we'll get this project done by March the 24th,
Yeah.
I'm not saying you're guaranteed. I'm saying that based on, if I'm using something we have called a Monte Carlo simulation, if I'm simulating based on my past data, thousands and tens of thousands of possible outcomes, 85% of those finished on or before this day, there's still a chance that, we do everything well and we hit the end of March, beginning of April. That forecast wasn't wrong. There's just always a possibility
Yeah.
that you're going to be on the flip side of that. And you can never, even if you account for all of your outliers, you can never be 100% certain
Hmm.
about anything unless it's already happened.
Yeah.
Because no matter how you're forecasting, something can always happen that never happened before or that you didn't anticipate. So we
Hmm.
just have to get away from this concept that we can give you an absolute deterministic forecast.
Yeah.
So moving people towards probabilities and understanding that is really important. To get people there, though, it'll take them much easier. It'll be much easier to get them there if we work on stabilizing our systems and help them have a little trust in that. Again, going back to what I had said before, if you have really unstable data,
Yeah.
to get like an 85 or 90% confidence, there could be a lot of padding in that estimate
Oh
because
yeah.
you're accounting for really extreme outliers.
Yeah.
So it's a trade-off.
So Julia, you shared a lot with us. Any closing thoughts?
Yeah, I think that first thing, start tracking when you start work and when you finish work. So you
Hmm.
can, with those two pieces of data, you can get all the metrics you need to start improving predictability and start forecasting. And then if you don't do anything else, pay attention to the age of the work that's in progress. If that's all you pay attention to, it will lead you to many of the other things people always recommend, like limiting your work in progress and all of that. You'll naturally realize you need to do those things if you pay attention to how old things are. So if you just do those things, start somewhere and track your metrics, monitor your work item age, you will naturally improve predictability and therefore make your forecasting more accurate and less painful to do.
Excellent. Julia, thanks for coming on.
Yeah, thanks for having me.
On behalf of Julia Wester, I am Tom Hendrickson for the DevOps Online Summit.